Okay, so let's go ahead and take a look at this objective. So what you're looking at here is I just didn't give you guys the equation. So I'm giving you guys the chart, and I want you guys to interpret the chart based upon the information that's given. So find all the x coordinates for the relative extrema on this domain. Now, what you notice is that this is symmetric with respect to the origin. That means that this is only half of it. So there's another half on this other side that's reflected. And so you think about a parabola, right? Parabolas are symmetric across the vertex. Same thing, but now I'm symmetric with respect to the origin. So when I'm looking at extrema, so I have x is equal to 1 because I changed from positive to negative with f prime. And then I also have negative to negative here. So at x equals 3, there's no relative extrema because I don't change. I had to change from positive to negative or negative to positive. So my only one is negative 1. But it's also true on this other side over here that I have x is equal to negative 1 also because it's symmetric. Are relative maximums because f of x changes from increasing to decreasing. And that's what it means to justify your answer too. This part here, because it changes from increasing to decreasing. Or I could have said because f prime goes from bigger than 0 to less than 0, or f prime goes from positive to negative. But the more, the better justification is using what happens with f of x. Okay, and then points of inflection. So now again, it has to change concavity. So here it's concave down and concave down, so that doesn't work. So the only one that I have is positive to negative, which is also at x is equal to 1. So at x is equal to negative 1 and x is equal to 1, f of x has a point of inflection. Because f of x changes and it's concave up from concave up to concave down at that value. Okay. So here, just be careful. It's the same exact thing, but the only difference is that determine the intervals when negative 2 times f of x is increasing or decreasing. So I'm not just looking at f of x. I'm looking at what happens when I take my negative 2 and multiply it by f of x. Okay, so this negative 2 just tags along the whole time when I answer all these questions. Okay, and this, I guess, is the quote-unquote easier one. So writing the equation of the tangent line, I want f prime of x first, and then I want f prime of negative 2 second, and then I'm going to use y minus y1, which is 17, is equal to f prime of negative 2 times x plus 2. And that would be my equation of my tangent line. I'm not doing this one all the way through because this one's a little bit different, and I want you guys to try it on your own only because what we're doing is we just did this in a couple of objectives ago where we did a review also, and so you guys should get to a point where you should be able to look at different keywords and be able to know what you're supposed to do. Relative min and relative max, I want f prime of x equal to 0. Then I want the chart. And then you have to see for max, there's my alarm to go off. For a maximum, I want increasing, Remember, I want increasing to decreasing. And then for min, I want decreasing to increasing. When I justify my answer, I will say f of x has a relative max at, because f of x changes, from increasing to decreasing, and f of x has a relative min at, and it should be a coordinate point, right? And you can have more than one as long as they have the same y value. From, because to increasing. Okay. Points of inflection, I'd want f double prime of x equal to 0. I want the chart with f double prime, not f prime. And then my points of inflection, I would say f of x has points of, and that's to justify your answer, inflection at whatever, because f of x changes from concave whatever to concave whatever. So like up to down, down to up. And that's it for this section.